Integrated circuits, which means dissolving away the epoxy package and exposing the die so that you can either see what the die looks like and figure out perhaps what the circuit is, or just probe the die while the chip is powered. So let me show you how I did this. Initially, I started just using a Dremel to remove a lot of the epoxy package material, but I found that was very inaccurate. As it turns out, the acid etching process, which I'll describe later, is very dependent on having a uniform pocket for the acid to sit in. So for my first real attempt, after playing around a little bit with the Dremel, I decided to use the CNC mill. So I drew up a little pocket in the CAD tool and then mounted the IC in the CNC vise and got it carefully set up and then milled the pocket out. So I had a really nice, even, consistent depth pocket. And for these chips, I've been decapping just 74 series logic and 4000 series logic, all 14 and 16 pin dip packages. And the thickness that I've been removing is about 40 to 50 thousandths from the top of the package. So I could probably have gone a little bit deeper. The trick is if you go too deep, the bond wires get cut and then you can't run the chip, which may or may not matter, depending what you want to do with the decapped chip. So after I had the pocket milled, I blew the dust out, and then initially I tried to etch the package away at room temperature. So I put a drop or two of fuming nitric acid into the milled pocket and waited for a while. But at room temperature, it's either going to take way too long or it's not going to work at all. So I started up the hot plate and then put the ICs in a little ceramic container and put that on the hot plate, and then put the drops of nitric acid into the milled pockets while it was all on the hot plate there. And I got it up to maybe around 100 degrees C. Some of the vague instructions that I found on the web indicate maybe 140 degrees C even. But the temperature seriously speeds up the reaction. It speeds it up so much that you can put just a very small amount of nitric acid in the pocket. You don't even really have to fill it up all the way. And the heat will cause it to bubble and froth, and eventually it sort of dries out. I'm not really sure what's happening there, but the liquid either soaks into the package or it dissipates. And so you can put a drop on and then wait 5 minutes and put another drop on, and it sort of keeps it very moist but not overflowing with acid. If the acid touches the dip leads, it fumes vigorously and is obviously dissolving away the metal, which you don't really want. So periodically I would take the chips out of the hot plate container and rinse them in some acetone, and then I'd use the acetone wash bottle to kind of blow out as much dissolved epoxy that I could. After a few iterations, I could see that the die and most of the bond wires were exposed. So I took it out and soaked it in some clean acetone and rinsed it again, and then put it under the microscope and had a look. And sure enough, the bond wires are all intact. Everything looks okay. The die is visible, and you can clearly see what's on the die. I haven't really done a whole lot of careful consideration about what I'm actually going to do with these decapped chips. I was mostly interested in just playing with nitric acid, and this is one of the cool things you can do with it. Obviously, gun cotton and flash paper will be coming up. I'm not really sure if you need fuming nitric acid to do this or not. I heard that you do, and going through all the hassle of getting nitric acid is difficult enough, and so getting fuming versus just concentrated was not that big of a deal. The difference in difficulty. So concentrated is like 68%, and fuming is as close to 100% as you can get it, basically. There's also white fuming and red fuming nitric acid. The red fuming has a lot of nitrogen oxides dissolved in it, and the white fuming is relatively free of nitrogen oxides. Okay, well, I hope you enjoyed that. Let me know what you think I should do with these decapped ICs. I've been thinking I'd like to probe them while the thing is running. I don't really have probes small enough to do this, but maybe I'll decap a larger chip that's cheap enough to do, just to kind of play around with. I think I've got the technique down almost well enough where I wouldn't have to worry about destroying the chip, but I'm still kind of getting the hang of this, so you wouldn't want to start with an expensive chip. Okay.